In this video, I'm going to be talking about inverse functions. So basically, the inverse of a function undoes another function. So let's say we had a function f of x. Well, we'll just call it f, actually. We'll have a function f, and f goes from 1 to a, 2 to b, and 3 to c. So we apply f and we get to a, right? We get to b and we get to c. To undo f and get back to 1, get back to 2, get back to 3, we must take the inverse. So the inverse of f now goes from a to 1, b to 2, and c to 3. It reverses the operation of that f did, right? So not every function actually has an inverse either. Note that a function must be 1-to-1 to have an inverse. And 1-to-1 just means that every element of the range corresponds to exactly one element of the domain. Basically, f of x never takes on the same value twice. And that's what 1-to-1 means. Another few things I want to add. Let's actually write down a definition for this. So the definition here, we have let f be a 1-to-1 function. Okay, this function f, so f has domain A and range B. Okay? We say that the inverse of this function, f inverse, we represent it with a little -1 there. And let me just get this straight right now. F inverse does not mean 1 over f of x, right? This, I'm going to write this in red. This is no. I'm just going to put a big X here. No. F inverse does not equal 1 over f of x. This is not what that means. What f inverse means is that we take a 1-to-1 function and we basically just flip the range, domain and range. So the domain, if we have a function here, the domain is A, the range is B. The inverse of f has domain B and range A. Okay, I don't want anyone making this mistake at the bottom here. The inverse of x does not, f of x does not mean it's 1 over f of x. So that's really it. F inverse of y equals to x, then, oops, let's do a little arrow here, then f of x equals to y. Okay, now let's get into an example. So there is a 4-step guideline for solving for the inverse. So basically, step 1 is to write down y is equal to f of x. 2, we solve for x instead of y. So we solve for x in terms of y. Three, we switch x's and y's. And 4, the result should look like y is equal to f inverse of x. So basically, if we had a function y equals x plus 1, we would just want to solve for x to find its inverse. So let's do an example. So the first step was write down y equals f of x. So here is f of x. We'll replace that with y. So y is equal to 2x cubed plus 1. All right, the second step was solve for x in terms of y. Pretty easy, right? It's just algebra, basically. You just have to kind of understand what the inverse is. So let's solve for x. So here's x on the right side. We're going to isolate it. So 2x cubed is equal to, we're going to move the 1 to the other side. So y minus, that's a terrible y minus 1. Now we have x cubed here. We'll divide everything by 2. So y minus 1, and then, of course, divided by 2 here. And now we have to, now that we have x all alone here, well, it's x cubed. We have to get the cubed, we have to find the cubed root of everything. So cubed root of one side, cubed root of the other side. We have x equals the cubed root of y minus 1 over 2. And now the last step is basically just replacing this x here with fx inverse, f of x inverse, and replacing the y's. Remember, switch x's and y's. So if we switch x's and y's, we have that y is equal to the cubed root of x minus 1 over 2. Now we get rid of our y here and we replace it with f inverse of x. And that's how you find the inverse. So basically you just solve for x. You're given some function, f of x equals 2x plus 1. We replaced f of x with y, so then we could, solve for x in terms of y. We solved for x, and we replaced our y's with x and our x with f inverse of x. And that's basically it. So our function was y equals to 2x cubed plus 1. The inverse of this function, f inverse of x, is equal to the cubed root of x minus 1 over 2. Of course, this y is actually f of x. And that's basically it. Pretty easy. So thanks for watching this video. Make sure to subscribe and continue following my calculus and pre-calculus series. Have a great rest of your day.